Dots of pale blue that sit in this void at NASA did not launch it at the time. Comprehend that the Voyager mission will become one of the most successful missions. Voyager was one of the first space missions in history. Since the 1970s, investigations have devotedly observed not only the planet Earth but also everything in our solar system. Despite having a memory and computing capacity that is 3 million times lower than our smartphones, which are 38,000 times slower than the fastest internet we have with 5G, these extraordinary spacecraft have consistently supplied humanity with new and amazing information regarding space. Voyager 1 has now made frightening discoveries in the depths of space between stars, causing the government to act decisively by putting an end to this storied mission. What exactly happened to Voyager 1, as well as the possibility of an extraterrestrial invasion? Let's find out. When it comes to Apollo, it was one of our space missions that takes the spotlight for achieving success by putting the first people on the moon. However, there is unquestionably a remarkable mission that stands out alongside Apollo, the Voyager mission. This extraordinary undertaking not only holds the record for the longest-term space mission, but also possesses the advantage of being the first to investigate the solar system's outer planets, comprising Jupiter, Saturn, Uranus, and Neptune. Specifically, the Voyager probes are thought to be the best for potential interactions with life on other planets as a result of their comprehensive preparation. Each Voyager spacecraft possesses an impressive gold record containing a sound collection, greetings, and images from Earth, serving as a representation of humanity and a showcase of the rich diversity of Earth. It is a gift to any possible alien civilization that might applaud, but what if these extraordinary probes confront a hostile race of extraterrestrials? Based on the signals we are currently receiving, this may be what Voyager 1 is currently facing. Scientists have been left pondering the possible outcomes, as this kind of encounter may prove to be more disastrous than anticipated. Keep observing as we investigate the factors that contributed to the government's decision to pull the plug on Voyager 1 and discuss the possible implications. But before we get to those specifics, allow me to introduce you to some significant context of Voyager. On September 5, 1977, Voyager 1 set out on its space odyssey. It was launched from Florida's Cape Canaveral on the Titan IIIe Centaur rocket into space, just 15 days after Voyager 2, its twin, began its very own celestial expedition on August 20th, 1977. Their main objective was to examine the enormous gas giants of Jupiter and Saturn and the orbits around their moons. But these daring travelers surpassed all expectations by venturing deep into our cosmic community, breaking a number of records along the way. They have outperformed every other spacecraft that has lasted and have traveled farther away from Earth than any other object made by humans. Surprisingly, they even broke into the threshold of space between stars, exploring uncharted territories of our galaxy, where Voyager 1 and 2 are currently located, more than 12 billion miles away from our planet. They continue to amaze scientists with their amazing recent discoveries. They made an unexpected revelation that attracted the entire research community. Presently, the twin Voyager probes have mastered extraordinary feats. More than 40 years ago, they unveiled the mysterious moons of Jupiter and Saturn, which left researchers astonished. These celestial bodies, once thought to be lackluster and ruin-ridden in the same manner as our moon, were revealed by Voyager to have a lively and dynamic nature. In 1986, Voyager 2 made history as the first and only spacecraft to venture to Uranus, followed quickly by an exciting meeting with Neptune just 3 years later. As these magnificent spacecraft keep going with their odyssey, NASA has employed clever measures to ensure their longevity by eliminating unnecessary power for heaters and components, preserving the spacecraft's ability to remain robust, at least, until 2030. The devoted researchers and engineers of the Voyager missions were shocked when astounding new information was so mind-boggling that the government was prompted to assist NASA in one of its most important projects. But before we talk about that, The reason for the Voyager mission's reputation is clear. How did Voyager achieve this significant victory? It changed our perspective on space and is one of the most famous missions, like Apollo 11, the Hubble Space Telescope, the James Webb Telescope, and the Mars rovers. Voyager, the legendary Space Telescope program, is a shining example of motivation for generations to come of researchers and astronauts. The information sent by the Voyagers has provided priceless insights, sparked a number of scientific discoveries, and ignited the creative juices of space enthusiasts and researchers across the globe. It is important to emphasize that Voyager 1 and 2 were unlike any other spacecraft. They were carefully designed to function as solid foundations with a rate of rotation more than 15 times slower than a clock's hour hand. Because of this deliberate design, data and images did not blur as the spacecraft navigated the vastness of space. Their impressive imaging capabilities continue to astonish public and scientific communities alike. Even prior to their interactions with the planets beyond Earth, as the spacecraft traveled, they began sending back images of Jupiter a number of months prior to reaching the massive planet. These initial images of the iconic Great Red Spot and the whirling clouds occupied NASA's Jet Propulsion Laboratory with joy. But it was the revelation of Io, the moon of Jupiter, with active volcanoes, that truly captured the highlight. Io, slightly bigger than Earth's moon, emerged as the most volcanically active body in our solar system. The spacecraft's instruments detected unusual signals emanating from Io. These remarkable captures were confirmed by findings revealed by these images: plumes from volcanoes and a surface marked by the release of volcanic gases and material. One of the most well-known volcanoes on Io erupted at heights that were a staggering 30 times Mount Everest, encasing an area very similar to the size of France. Over 33,000 images were taken by the spacecraft, revealing the breathtaking beauty and amazing variety of the Jovian scenes of Jupiter and its moons. Before moving on to the astonishing new discovery, it is important to keep in mind that the twin travelers have been finding a wealth of amazing results since their significant launch. One of the most astounding revelations was the existence of Jupiter's rings, which, despite being small, added an additional layer of suspense to Voyager 2. A massive gas giant exposed the icy shell that covered Europa, one of the 53 named moons of Jupiter, believed to have a thickness exceeding 60 miles. These groundbreaking results challenged assumptions previously held about these far-off heavenly bodies, rekindling passion in investigating the possibility of life on icy moons. As the travelers said their goodbyes to Jupiter, they received a boost from gravity that allowed them to move toward Saturn's enchanting world. Without this clever move, their escape from the gravitational well of the Sun and their subsequent excursion into the depths of space would not have been possible. As Voyager 1 and 2 embarked on distinct paths, each moved toward unknown frontiers, eagerly awaiting the discovery of new wonders. Voyager 1 set out on a course that took it close to Titan, Saturn's moon, which is surrounded by an orange haze. Scientists became interested in the atmosphere's mysterious nature, encouraging them to carry out additional studies on its complexities. Voyager 1's course then changed and moved in the opposite direction of the ecliptic plane, beginning its remarkable trip beyond the limits of our solar system. In the meantime, Voyager 2 began a thrilling sequence of escapades that led it to the outer planets in our cosmic neighborhood. It achieved a historic milestone in 1986 via Uranus's flyby, where it found 10 previously unknown moons, boosting the count of this planet's moons. Voyager 2 made it to Neptune 3 years later, showcasing the exceptional characteristics of the distant ice giant. When it came into contact with Neptune, the spacecraft recorded wind speeds of up to 1,000 mph, the fastest ever witnessed on a planet. By zooming in 2,180 miles from Neptune's methane atmosphere, Voyager 2 provided unparalleled perspectives on this faraway moon. Neptune's largest moon, Triton, proved to be one of the coldest places in our solar system, with bone-chillingly low surface temperatures of negative 391 degrees. Additionally, Triton had distinctive features like ice volcanoes releasing icy particles and nitrogen gas up to 5 miles high within its thin environment. These discoveries grew our comprehension of the extraordinary diversity and complexity of celestial bodies that reached even further reaches of our cosmic community. One individual whose contribution was crucial in going beyond the scope of their mission's initial goals was the prestigious Carl Sagan, an astronomer and a member of the imaging team for the Voyager missions. He fervently advocated for the capture of images. Before turning off, both spacecraft had cameras. These images of the spacecraft would be used as a final present to humanity, offering a last look at our home planet from the faraway reaches of space. Sean's Valentine's Day proved the value of perseverance. In 1990, Voyager 1 retracted the camera in the direction of the inner solar system and took a set of 60 photographs. These are among the most well-known images, referred to as the pale blue dot, which remains a lasting reminder of our position in the universe. Seen through an incredible distance of 3.8 billion miles, it is the planet's farthest image ever taken. Earth appears as a tiny pale blue dot, barely discernible in the vastness. This mission has been ongoing in space for nearly 50 years, leading many to contrast it with earlier space missions, one of which resulted in impressive contributions to science, the James Webb Space Telescope. Despite the fact that their goals differ, the Voyager missions have pushed the limits of human understanding and improved our comprehension of the universe. The Voyager 1 and Voyager 2 spacecraft have been at the forefront of space exploration, still investigating and sending valuable data back to Earth right now. In contrast, the James Webb Space Telescope, launched in 2021, marks the start of a new era in space. It's a large telescope optimized for observations in the infrared, with an emphasis on investigating the formation and evolution of galaxies, stars, and their environments. By looking at them in the infrared, the JWST's spectrum will reveal hidden cosmic events and supply unprecedented transparency in our investigation of all things. Both projects have extended the capabilities of technology and engineering. The Voyager spacecraft's advancements were marvels of their era, armed with modern systems and instruments that made it possible for them to withstand harsh conditions and maintain communication with Earth across vast distances. Similarly, the JWST incorporates cutting-edge technologies like deployable solar cells to safeguard its delicate instruments from the heat of the sun and a large segmented mirror for capturing faint infrared signals. While the Voyager program focuses on our cosmic neighborhood, the JWST's goal is to decipher the universe's mysteries on a larger scale. Its advanced capabilities will allow researchers to look back in time at the earliest galaxies, bringing clarity to the formation and development of our cosmic environment. What tactics were used to ensure the success of the Voyager missions? In 1977, in August and September, NASA began a monumental project that would forever alter our perception of the universe. With unwavering resolve, 2 robotic spacecraft were launched into the vastness of space using a groundbreaking method known as gravity assist. These maneuvers would turn out to be the key that opened up the mysteries of the solar system and pushed humanity forward into the unknown realm. Picture a cosmic ballet in which the spacecraft embraced the powerful gravitational forces of planets, with grace, using their power to reach their destined places. Instead of relying solely on their engines, the Voyagers elegantly used the colossal might of these celestial giants to propel themselves across space. It was a stroke of genius on the cosmic stage, a clever move that conserved valuable fuel and moved the spacecraft at unprecedented speed, allowing them to begin an extraordinary trip through the solar system. The method referred to as the gravitational slingshot lies at the heart of this approach. As Voyager 1 approached Jupiter, a magnificent gas giant with a gravitational force that defies understanding, it required careful planning to achieve a perfect encounter, handled with extreme caution. Voyager 1 gracefully struck Jupiter, utilizing its gravitational force to accelerate with an energizing cosmic force that propelled it further into the depths of space. Carrying out such a maneuver required a high level of skill. A single mistake in Voyager's approach to Jupiter might have meant disaster, sending it off course and putting the entire mission at risk. The required level of precision was remarkable, but the brilliant minds at NASA's Jet Propulsion Laboratory survived the test, composing the choreography of these celestial ballets not once, but several times. With the help of gravity assists, Voyager 2, aided by Jupiter and Saturn, set sail on a daring trip to Neptune and Uranus, completing the enlightening Grand Tour. It was an accomplishment of human genius and exploration, owing an incalculable debt to the finesse and precision of these maneuvers. Voyager 1's exploration, aided by gravity, boldly ventured into interstellar space, closely followed by Voyager 2, driven by the forces of the cosmos. While the idea of gravity assist may appear straightforward, its execution demonstrates the dedication and brilliance of the people behind these projects. The Voyager 2 completed the Grand Tour with meticulous precision. A single misstep in a slingshot might have spelled doom for the mission, but with obstinate tenacity, these pioneers of exploration pushed the limits of what humankind could accomplish, driven by an unquenchable thirst for knowledge and a fervent desire to discover the answers of the universe. Gravity assist maneuvers played a crucial role in navigating the universe on the Voyager missions. They were not the only ones to carry out the accomplishments of these daring projects. Enter the Deep Space Network, DSN, a link between us and our intrepid Voyager spacecraft as they entered uncharted territories. Consider it a network for interstellar communication, a web of enormous radio antennas strategically placed across the globe. These monumental dishes, ranging from 26 to an incredible 70 meters in diameter, served as cosmic lighthouses, facilitating vital communication with the spacecraft orbiting our planet. Envision the Voyager mission as an enormous odyssey driven by an extraordinary artifact, the 8-track tape. This amazing object serves as a cosmic time capsule for valuable scientific information, overcoming the vastness of the universe. Unlike typical consumer 8-track tape cartridges, the recorders on the Voyager spacecraft were an engineering marvel, incorporating a real-world storage system manufactured by Lockheed and designed by the AX Corporation. These impressive machines had particular requirements. They used a belt-driven mechanism and a 1.76-foot-long, 12.5-millimeter-wide, 328-meter-long magnetic tape featuring 8 distinct tracks. These recorders provided adaptability and precision with recording speeds of 1150, 72 kilobits per second, and 52 kbps, whereas playback speeds ranged from a maximum of 576 kilopascals per second to slower alternatives of 336, 216, and 72 kilopascals per second. Relying on these extraordinary 8-track tape recorders, the Voyager mission is an example of humanity's steadfast commitment to scientific investigation. As these inquiries venture deeper into space, this timeless relic's legacy continues to maintain and spread our unquenchable thirst for knowledge. The Voyager missions have sparked wonder in each of us, driving us to venture out into the expanse of interstellar space. Before delving into the findings that resulted from Voyager 1's shutdown, let's look at additional intriguing interstellar missions: Pioneer 10, Pioneer 11, and New Horizons. These missions have played an important part in advancing our knowledge of the universe and pushing the limits of human curiosity.